Okay, there was two things I wanted to do. One, I kind of looked at your work from the test, and there were two questions that people had a little more trouble with. And so I thought I would do those real first right away. The first one was find the ratio of, this was just one example because everybody had a slightly different problem, 0.7 to 14, okay? And so they want it reduced and everything. So this is a fraction. The 0.7 goes here, the 14 goes here. Most people got this part correct. They knew what to make it a fraction. The question was, what do you do next? And with a fraction, you don't want a decimal in part of the fraction. And so what needs to happen is this decimal point needs to go over here. Now this amounts to multiplying because you're making 0.7 into 7. And so you're multiplying by 10. So if you multiply this one by 10, you have to multiply this one by 10. So what that amounts to is when you multiply by 10, it's a decimal shift. And so this becomes, the numerator becomes 7. When you multiply 14 by 10, this becomes 140. So that's the trick. That's what we're trying to do. And so this literally moved over one place as well. And so that's why it became 140. This is not reduced, but this is so much easier than the original. So you divide by 7. 7 into 7 is 1. 7 into 14 is 2, and then into 0 is 0. That was the answer they were looking for. So I just wanted to remind you, when you see a decimal within a fraction, the best way to do it is just to clear it by multiplying by 10 if it's one place, or 100 if it's two places, that kind of thing. I think that will work. The other problem was this. If 6 ounces of orange juice cost $1.26, like that, what is the unit price? And so they might have said, you know, what is the cost for 1 ounce? But they might have said unit price. I forgot what it was. But basically it's cost per ounce. So you have two approaches. One approach is the proportion. 6 ounces cost $1.26. 1 ounce would cost X. So that would actually do it. The other one is, they might have said, and I can't see the problem right now, but the unit price, they might have said cost per ounce, right? Like that. And if they gave you that instruction, then you would go $1.26 divided by 6. And I believe the answer is 22 cents. That was not the problem. Many people got this. And so this is 22 cents, and it is in terms of dollars. So as far as a dollar is concerned, you have a fractional part of a dollar, which is 0.22. Here's that front 0. The problem was, here was the space for the answer, and here was the word cents. So if you put 0.22 in this, it's saying it's a fractional part of 1 cent. This is in terms of dollars, and so it's a fractional part of a dollar, but in terms of cents, the correct answer should have been 22. Now, I'm assuming I wrote the answer down right, and you know, somebody could double check my work, but that's not the point. The point is, you did get this answer, let's say, but when they called for cents, how many pennies? 22. And so this is in dollars and this is in cents. I see this error a lot. because this is 22 cents. That's how you'd say it, but it's in terms of dollars. Whereas this one here, and any question about that? So that was where the error was made. It was from here to here. Now, the other thing, I wanted to do a couple of problems from 6.3 before I go on. And 6.3, these were like story problems, word problems. And one example was the one that was just mentioned about a mixture. So here's a container and what it has, and so I'm going to break it up. 60% alcohol, right? And the implication is the rest of it is water. Now, if somebody said, well, how much water? Well, it's 40%, but that's not what they asked. But if they did, that would be the answer. The other thing they did was actually, as a percentage, this doesn't really tell you how much in milliliters. And so they literally said, this is 42 milliliters. And so the question was, how much is the thing in total? In other words, the alcohol part and the water part. So I showed you two ways to do these problems, and you might, this way might work very nicely for this problem. The percent over 100, and this is percent of alcohol, because that's what we're given. So that's percent of alcohol. This over here would be the amount of alcohol. This would be the total of the whole thing. We do not know the total. Okay, but we do know the amount. And so this is corresponding to the percent. And so the amount is 42. So here's the correctly set up problem. 42 to X, and the percent for 42 was 60. Okay, you then cross multiply, and this is a correct setup. Remember, there's more than one way to do it, but I think this might be more intuitive. Because they gave you 60%, we've got this right side of the equation all done. The only problem was to try to figure out, is 42 a total? And there were two clues. One, 42 was about the alcohol, so it wasn't the total. And two, they said, what's the total for both of these? And so clearly total is missing. That puts 42 in the part here. We could call this the part. Okay. The cross multiply, I think you can do. Can you do it? Can everybody do that part? Do I need to do it?
So 4,200
4,200
over,
equals, don't forget the equals,
oh,
equals 60x. This is 60 times x. You divide by
divided by 60.
Cancel, cancel, x, which is the total. And you could have, see, a picture's worth something, right? Because then you're starting to visualize, oh, I'm mixing these two things together. Here's my total container. I can take out a pair of zeros if you feel like it. 6 into 42 is 70. And so that would be 70 milliliters.
Oh.
I think that might be the easiest way to go. What I wanted to do, any question about this? This may not be your best way to do this, but I think it might. Let me try another one a few more. This is about test scores, okay? The student answered 81 questions correct on a test that was 90, was the test, 90 question test. What percentage did the person get correct? And finally, what percentage did they get incorrect? Well, if we can get one, we can get both. This may strike you because this is something you're so familiar with that you kind of know what to do. If there was a total of 90 and you get 81 correct, then this is what we're dealing with. This is what we actually want to find out. You get 81 out of 90. Now I'm going to reduce this by 9. 9 into 81 is 9. 9 into 90 is 10. They wanted a percentage. And so 9 out of 10, can you make that a percentage? Well, if you went with this approach, you would have to, 9/10 is 0.9. And if you remember when you had a decimal and you wanted to make it a percent, it went 2 places to the right. And so that's a 90% score. Does that sound right when you get 81 out of 90, that you'd have a good score like 90?
Yes.
Seems right. And then once you know that's 90, then this, of course, it must be 10. Now, let's say this did not come to you, that this was the correct thing. The percent, we don't know. So this is this approach. Sooner or later, one of these approaches will work. The total must go on the bottom, and we do have it, don't we? So the 81 has to go here. Now, the advantage of this would be 81 times 100. I'm going to write over here, 8100 equals 90 times x. Same. Cancel, cancel. I'm going to hit out one pair of zeros. 9 into 81 is 9. 9 into 0 is 90. Now, why did I get 90 this time? Because this is indeed the percentage. And so when I use this form, this is giving the actual percent. I don't have to be finagling. How's that? What do you think? Anybody?
I like it.
I think it has potential. The next one is about basketball scores. A person made 63 out of 75 free throws. What percentage? That's the question. Isn't this the same question? Just because it's basketball, who cares? Right? The percent is here over 100. You could actually call this P if you wanted, for P for percent. Can you tell 63 out of 75? Even the word of is used so often. The word of, 63 out of 75.
So multiply.
No, the word here is used to mean the total. It precedes the total.
Oh,
So
yeah.
75 is the total. There was more to this sentence. I understand what you're saying is the word of can be used to be multiply, but 63 of the free throws out of 75 total, that makes this 63. Okay, and so then what do? You cross multiply. Okay, I'm gonna leave that multiplying to you. Here's another chemistry problem. How much acidic acid is in? So it's a 5-liter container. Okay. And the water, it's acetic, so it's the acid plus water. That's what it is. So there's a container that has acid and water. Okay. Now, the container is 5 liters. Okay. And one more fact, so we can do this. It's marked as 80% acid. So this is a container, 5 liters. It's marked as 80% acid. So I'm going to kind of do it like that. This will be the 80%. This will be the acid. This will be the water. Okay. So if somebody asked how much water, you would have to say 20%. But they may want to know exactly in this. So the question is, how are we going to do this? So can you find a way? We need to know how much acid that is. Now, if the total is 5, it'll probably be less than 5, maybe 3 or 4, right? Does that make sense?
Mhm.
And so can we set this up the same way we've been doing? Let me see, what was the question they wanted? How much is water? So if this is 80%, this is the acid. And this would be 100. What? I only have one other piece of information, was this 5 liters. Where does it belong?
X over 5.
Correct. In other words, that's why I drew the picture. You know, you may not like my picture. I'm sure some of you can draw more beautifully, but it was the total container that contained acid and water. So the question is, we have 3 out of 4 in this proportion. This can be solved. So this is X times 100, which I would write as 100 times X equals 5 times 80. 5 times 8 is 40 with a 0. Divide, divide like normal. Four liters. Does that seem right? This would be 4 liters. If somebody asked, this would be 1 liter. How's that? The 5 belonged on the bottom because it related to the total. Okay. Question about that? I got one more. In a certain school, 75% of the students in chemistry had algebra. Okay. That's my sentence. If there were 300 students in chemistry, question, how many had algebra? Okay, these are words. Notice how I get them down to as few words as possible. So although the sentence was nicely worded, long sentences and so on, I only wrote down what I thought mattered. And so here's, I'm just going to draw a box. So this is 75%, this is 25%. These are the ones that had algebra, these are the ones that did not. Which group do you think did better? Everybody should have taken algebra. That was my conclusion on this. 300 students in chemistry. Where is 300 a part or a total? That's what I need to know.
The total.
It is a total. So once you determine that it's a total, and then this would have to be X. And so this, we're trying to figure out the ones that had algebra, right? And so the ones that had algebra were 75%. So that was the number we had to use. We
I got
used the
225.
300 for total. Is that okay?
Yeah.
And this is ready to go. And so Chris cross multiply. I hate to almost bring this up because I'm so worried that people will misunderstand this. You can reduce this on one side of the equals. You can't do it like you do in multiplication, but you could turn this into 3/4 without harming the problem. Why do I think I want to do that? It'll save me an awful lot of work. X times 4 is 4x. 300 times 3 is 900. And so what I would do is divide both by 4. Keeps my numbers down, but if you do it and make a mistake, don't do it. So what we have here is the 75% stands for 225 students. This was a total of 300. So once you visualize this picture, 225 had algebra, then if somebody asks you how many did not, you can clearly see the relationship here. This would have to be 75 to make this total to be 300. I like pictures. I don't know about you, but I do. It's almost like you can see the relationship there. And any question? What I wanted to do is 6.4, which is sales tax.
Uh-oh.
And also commission. So here's our first problem. There was a sales tax in Mississippi, 7%. And somebody purchased something for $550. Question, how much tax? Okay. Two approaches. It's fairly, you're pretty used to sales tax, especially in Seattle. And so the simple way to do it is to say, what is 7% of $550? That's it.
38.5.
It's just multiply, right? And this is telling us this has to be turned. So this is going to be our answer. 0.07 multiplied by 550. And then you do it. You know, if you get $1,000 by mistake, you have to say, am I going to pay $1,000 tax on something that's $550? Answer, no. And so this is where I jokingly say, do you care? If it was your money, you would. 0, 35, 35, 38. So I'm getting 38.50. Okay, it's just a matter of multiplying that crazy number. Okay. in Seattle, it's 10% or something very close to 10%. And so what is 10% of, what do we want to buy? Anybody? You're not interested in purchasing?
A banana.
A banana, how much is, well, banana, isn't that tax
No,
exempt?
it's not taxable.
Oh, yeah.
Does anybody know that? Sometimes food is not taxed. We have to buy something else. What
About a
do
bottle of water. They tax on that these days.
they do? How much is water?
Let's say it's $1.89.
$1.89. Okay. All right. So if they're going to tax it, let's say they are, whatever this is, doesn't matter. So we want to go, X is 10% multiplied by $1.89.
So it's 18.9.
This is a decimal shift. 10% is 1/10. It's dividing by 10. It literally just, the decimal comes over here. The answer will be 0.189. So how much would they charge you if that's the tax? Would they charge you 18 cents?
19 cents.
No, they always go up. That's one thing about stores. They always go up. That's a rounding rule for stores.
Mhm.
Seriously, they always go up. Even if it's 0.1, they always go up. They make a little money that way. So the tax would be like that. Or if they wanted it in cents, you would tell them 19. If they wanted it like this, you would do it like that. Is that okay?
Yeah.
Seattle makes it, well, it's expensive, but it's easy to compute. Okay, here's an example. The sales tax in this place is 4%. It's on a bike, and the tax, I don't know what kind of bike, but the tax is $5.44. What is the total? Oh, isn't that nice? Total price of the bike. Okay, so I'm giving you the key information. The sales percent is 4%. The tax that was charged was $5.44. What is the total price? Right? Now, sometimes we'll go this way. And this would be 4%, which is 4 over 100. Where does this number go?
On top.
It's on top. It's the part. And this is X. So I'm going to actually do it because we have another step to do. I take 5.44 times 100. That's a decimal shift of 2 places. That makes it 544. 1, 2. Equals, this way, 4x. I need to divide by 4, and I'm hoping this comes out beautifully. 4 into 5 goes 1, 1 left over. 4 into 14 goes 3, 4 times 3, 2 left over. 4 into 24 goes 6. So that means the bike, this little bike, whatever it was, is $136. If it was your money and you thought there was a mistake, you could take $136, multiply it by 0.04 to see that it did come out to the right tax. Now, this is the little extra thing. If they say how much, what the cost is it 136 or is it something different than 136?
You have to add the tax to it.
You have, everybody knows this. This is what you have to do, 544. So that's 44141. There's your number. Okay, you know this, everybody knows it. And doggone, if you have to ship it, that's another 10%. Maybe more, right? Isn't that about right?
Yep.
It seems like it to me. How's that? So I think, I don't know if this is working for you, but I have a feeling on some of these word problems, the 100 is definite. The percent is definite. Your real job is the one other number. Did they give you the total or the part? And once you know that, then you know where to place it. And I think that might make it simpler to manage. Here we go. Ah, here we are. Real estate agent gets 3%. You knew that. When they sell the house. This house was 289,000. This is not Seattle prices one bit. So I'm gonna make it more like Seattle. And that's still not much.
That's Tacoma.
Yeah,
Yeah.
you got to be outside of Seattle for that.
That's a chip house.
But they had 289,000. I couldn't deal with that at all. So let's just pick this number. So this is a commission that the real estate agent gets, 3%. And so we're basically, you can go, what is 3% of 450,000? This is just a multiply problem. We could do it the other way, but I'm going back and forth so that, this makes sense here. So I'm going to go 450, 1, 2, 3 times 0.03. I have 4 zeros here, 1, 2, 3, 4. Then I have a 15. And then I have 12 and 1 is 13. 2 decimal places. 13,500.
Nice.
So sometimes they'll charge 6%, the real estate agent, and then 3% would go to the buyer, 3% to the seller. It just depends. But it can be a sizable amount. Right? Anybody have any experience with this? But anyway, that's a sales thing. And so we could do it all kinds of ways, but that's commission, sales price. Okay, here's one that's also about a house. Suppose the purchase, oh no, this is not about a house. So suppose the purchase price of a dining room set is $450. So you're gonna buy something. If the tax is what, $22.50, okay? What was the sales tax rate? In other words, what's the percentage? That's the question. I'm starting to go for this. We don't know the percentage, do we? I'm going to use P per percent. What goes here and what goes here?
2250 on top, 450 on the bottom.
2250, 450. You bet. Okay. I'm assuming people can struggle through. This is 2250 times 100. That's a decimal shift of 2 places. 2250, right? Multiply it by 100, 1, 2 equals 450 multiplied by the percentage. I'm going to divide and divide. I'm going to kill a pair of zeros. And I think 45 into that, I think it's like, anybody know?
20.
5.
Oh,
I cheated. Okay, so this is 5, this is 5%. So that was the sales tax. How's that? I think this will work for us. Okay. I'm gonna go over this next one. This 6.5 is percent of increase or decrease. Okay. So let's do salaries. So this particular one, the person is going to get a 5% raise. I like it. And in this particular example, their salary was 22,000. Okay. So we're increasing the salary by 5%. The question is, what is the new salary? Okay, we want to know. And so we need 5%. So you can do this all kinds of ways. We can go 5%, 0.05 times this. This will then represent 0.05 multiplied by 22,000. And it's 1,100. Is that the answer you turn in for the new salary?
no,
No, we know better.
23,100.
Yeah, we take the old salary. This is not just numbers, this is salaries. Right? We want to get this right. We want to know what that means, and that's what the new salary would be. Okay, so it increased. Okay, here's another one. There are a pair of shoes, boy, these numbers are small, originally that were $25, and now they're on sale. Guess it doesn't matter, they're keeping the number small, for 21. What is the percent of decrease? In other words, how much did they take off the original price to get to this price? Now, the trick is the meaning of the word decrease. Decrease is not $21. Decrease is how much it went down. Now, you're thinking, I'd like it to go down, the price to go down, and then the question is how much the actual decrease is 25 minus is $4. It went down 4. So in order to get the percent of decrease using this approach, this will be the percent of either, well, in this case, it's decrease over 100. This will be the amount of the decrease over the original. Because if we want the percent of decrease, then what we have to match it with the amount of the decrease. The amount of the decrease is not $21, it's 4. How is that? So let's proceed with this. So this is X over 100. Did we have the original amount?
Yes, 25.
It's definitely, that's the original amount. And so if this is the percent of decrease, this has got to be the amount. We have to put 4 here. Now, when we multiply this out, it comes out, I'm going to just multiply, it comes out 16. That means the percent of decrease was 16%. I did it real fast. Okay. But this part, I'm assuming if you take the time, you can actually do this. Okay?
Yeah.
So that's the trick. So I want to do it another one. Ooh, I need more paper.
Scary.
Here's how I want to explain increase. If something normally cost $100, and you go to the store and normally you would have spent $100, but instead the price has gone up. So let's say the price is now $120. What's the percent of increase? Now let's think about this. First of all, we're slightly annoyed that the price went up. But we had planned to pay $100. So the actual increase, if they just said, well, let's pay $100, you just said, okay, that's what I expected, that's what I'm going to pay. But they didn't. They said 120. The actual increase is not 120, but the amount it went up. So when you set this up, the percent of increase, I'll make it P over 100, a percent of increase, just to make sure. This has to be the amount of increase. What number goes here? It's the part you're annoyed about. You're not annoyed about 100, are you? Well, you didn't like it, but you were prepared. What are you annoyed about? How much?
120.
20. This is the trick about percent of increase. See, the word increase, the amount of increase is 20, and you get it by subtracting. And then over the original. Now, this is the thing. Then what's the denominator? This number or this number? It's always the original. Always the original. What did it used to be? And so that would be go over here. Now I made a problem that was so simple because this is going to be 20%. I think you can see when that's 100, that's 20, that's 20, that's 20% increase. Things are going up, right? Inflation, things are costing more. And so the real question is, what percentage are things going up? Well, how do they figure it? They always figure it on what did it cost last time? What was the original cost? Not 20 years ago, but what did it cost previously? And so that's what you have to work with. Okay. Let's see if I can find a decrease. Let's have something go down in price. What could it be? I can't imagine. Anybody have any clues? What could go down?
Gas goes down sometimes.
Yeah, okay. So let's make, it's getting expensive. What kind of, give me a price, a nice round number for gas.
$4 a gallon.
That's round. And it's going to go down to what?
$2.60.
360. Okay. Good. So this is a decrease. And so it decreased when you subtract the two, the decrease was actually 40 cents. Right? 40 cents off of that. So now let's see. The percent of decrease over 100. What's the amount of the decrease?
40 cents.
40 cents. That's your savings over which of these two numbers?
$4.
$4, the original. There's a lot of mistakes made this. First of all, people are trying to do 360 and $4 and try to make something out of that. That won't work. You need to subtract the two to see how much it went down. But then you still have one more hurdle. And the other hurdle is that you always go with the original amount. So the original amount could be more or less. But this is what happens. And so I'm just going to make this just 4. So 0.40 times 100 would be a 2 decimal shift. That would be 40. This is our x equals 4 times x. X equals 10. So this is basically a 10% drop. It went down 10%. If you cared, you would take 10% of $4 and that would be 40 cents. And then you'd say, I got this right. And then you could move on to the next question, I would say. How is that? I have one more I want to look at. It has to do with interest. And my goodness, there are 2 basic kinds of interest. And so the first one is simple interest. And if you're buying a car or something where you have to buy it over a period of time, the way to remember the formula is that it's the 3 things that matter when you buy something. And the 3 things, the first one they call P for principal. It's the amount of the purchase. The second thing is the rate. What percentage rate are you given? And the third thing is the time. So this is principal, which is how much you spend. This is the rate, which is a percentage. And this is the time. Usually it's in years. If this is in years, this is in years. So it's a fairly, if you bought something, you would, how much did the car pay? How much, what percentage rate were you given? What is the time? People have 5-year loans, 3-year loans, 6, I don't know. But typically that's it. Now, car loans tend to not be simple interest. But for now, this will help you remember the 3 items: principal times rate times time. So here's a bank problem. So a person put $2,000 in a CD account, and the percentage rate was 6%, which is awfully good. And it was just for 1 year. So the question is, how much interest did he have? And then how much total amount was in the account? Okay. Here's the formula. Principal was $2,000. The rate was 6%, and I'm going to immediately make it a decimal. Because I know I can't multiply by 6. I have to multiply by 0.06. And then the time, of course, was 1 year. So when you multiply these numbers, 2000.06, 1, 2, 3, 12, it's $120. So if they ask for the interest, you would say $120. If they ask for the total that's in the account, this is like before, just like when you added on the tax, this is adding on your interest. And so it's the $2,000 plus the 120 interest, 2120. How's that? You know how that works. Things are automatically done in the bank, you know, where they add on your interest. But I remember a good while ago, my aunt, she had an account and she had to go in and they would calculate it by hand. And she had to go in 4 times a year. But she wanted her interest, so she did it. But now, of course, everything's automated. But literally, that's the answer to that particular question. Now, there's a funny thing that they sometimes do, and I'm going to show you the funny thing. A student takes out an emergency loan for tuition, books, and so on. The loan is $600. Okay. The interest rate is 4%. How much interest does the student pay if the loan has to be paid back 60 days? So they're going to pay it back in 60 days, 2 months, basically. And we want to know how much interest will be charged. Now, they are doing problems. We all know there's 365 days in a year, but in this particular example, they're using a year is 360. Now, why are they doing 360? Because it then makes the calculation easier, and maybe you didn't need to know to the nearest penny, you just needed to know approximately what it's going to cost. If you do 60 days out of the 360, this is why they use 360. You could cancel this down, and 6 into 3 divided by 36 is 1/6 of a year. Okay. So this may mean we can do this calculation by hand. And so I'm going to go ahead and set up the formula. So in general, when you have something like this and you have a formula involved, the first step is to write the formula down. Principal times the rate times the time. Then proceed to drop the numbers into place in the formula. So the principal was $600. The rate was 4%, but of course, I'm going to put in this 0.04. And the time, this is 4% a year. This is in years. So this is 4%. It's not 4% a day, 4% a month, it's 4% a year. And so this is in years. This is 1/6 of a year. It wasn't the full year. This just made the computation easier. It's not exact. I mean, 365, if you're at the bank, they would do 365 and they would do it exactly, but we're looking for something approximate. I want to cancel a little bit of this. I'm going to do 6 into 600 because this is denominator, this is numerator. 6 into 6 once, 6 into 600 100 times. So regardless, this becomes fairly simple. 100 times 0.0 is a 2 decimal shift. That's $4.
Yeah.
Yeah, $4. It's worth it, right? It's not a bad loan.
No,
No. And so that's kind of what you wanted. So the use of the 360, you will see that in a number of these problems. And it really goes back to when people had to do things by hand. Now, I know we're kind of encouraging you to do things by hand, and the reason we are, as much as possible, is because then you have a feel for when things are wrong when you do them by hand. And so you won't always do your math by hand, obviously, but we try to do what we can so that we get off to a good start. Here's another problem. A woman deposits $900 in an account. It pays only 2% a year. If she withdraws all the money after 90 days, how much is in the account? Whatever. Okay. What happens is we started with $900. We added the 2% a year, but we only lasted 90 days. And then we take it out. So what we want to know is what's the total in that account? We know this is an interest formula. So the principal was 900. The rate was 2%. And the time, the reason I showed you this one is because it's another one of these 90 days is 90 compared to 360. They've set these problems up so that they work out pretty well without a calculator. So expect to do them this way. So 9 over 36 is 1/4. And so I'm going to put this over 1. I'm going to divide 4 into 900. I think it's got to go 4 into 900 twice, 225. 4 goes into 4 once. 4 goes into 900, 225. And so it amounts to 225 times 0.02. And that's 450. Wait a minute. This 450. 1, 2, 1, 2. Now what? In 90 days, we earned $4.50. So when she goes to pull it out, she will pull out the $900, obviously, and the $450. That was the interest on those 90 days. So it's $904.50. Does that make sense?
yeah,
So the main thing was this silly little thing about the 360. I mean, we have calculators, and I think everybody here has always had a calculator. And you probably know I just do things really fast. It's because I learned without one. And so that makes a huge difference, obviously. Now, I know it's almost time to call it, but I wanted to show you there is a different kind of interest, which is compound. And I don't normally test it. but most things are based on compound interest. So what happens is, and I'll show you an example. If the interest rate was 12% a year, and this was based on, it was compounded twice a year. What happens is, this is the timeline. So let's put in $1,000 right here at the beginning of the year. The way compound interest works, and so I just want you to have a feel for this, is that after 6 months, half a year, they would calculate the interest, but it wouldn't be 12%, it would be 6%. Half of the interest. That number would go here. Then, so what is 6% of 1,000? 60? 60. So it's 1,060. With compound interest, when you calculate your amount over here, it's based not on 1,000, but on 1,060. So you're getting interest on the interest. And so 1,060, 0.36. So what we're going to do is add $63.60 to the 1,060. Okay. And so can you see, instead of just always basing it on 1,000, it's interest on not only the 1,000, but on the extra. And so it actually builds up quicker with compound interest. So the formula requires a calculator, and it requires a calculator that will do exponents and so on. And so we can go through this. I actually have, I don't know, I have a TI-84. It literally will do all this compound interest business. And so we may work at it a little bit more. But this is the basic formula, and I think we're pretty much out of time today. So let's proceed. The assignment for 6.4, 6.5, and 6.6 is due Wednesday. And so we'll go ahead with that. I'm hoping there's enough information. We've done enough problems today so that you can have better luck with this. But you can go ahead and skip these problems. Or somebody might want to try to work through it. That's okay. And I may do some more on Wednesday just to give you an idea, but I don't test it, so I wouldn't worry about it too much. But the simple interest, yes. So there we go. Any questions? Everybody's so quiet today.
There is class on Wednesday, right?
We do have class, yes. There is class on Wednesday, and it's like always, it's recorded. So if somehow you can't make it. Yeah.
Cool.
Cool. All righty. So I think, yeah, I think we're thinking about Thanksgiving probably. At least some of you might.
I'm hungry.
Huh?
I'm hungry.
You're hungry already? Well, that's good. So, all righty, that's it. So what I'm going to do, I'm going to get out of this, and I had a small class today. What's going on? Think people? Thank you.
Traveling.
So, yeah, I don't know. What do you think? They took their vacation early?
Maybe.
I
Yeah.
don't know. Anybody need anything individually? Just stay. Otherwise. Yeah,
Thank you. Have a good
Thank you.
day.
Louis, I don't know what's going on with your screen. It's almost like you're there.
Yeah, I know I can see my nose, but I cannot see the rest of it. I can figure out later on.
Yeah, don't worry about it. I know you're there because you're talking to me.
Yeah. What's your Wednesday?
Okay, see you now. Okay, Tava, did we settle everything before class? Oops, wait.